Okay, quadratic inequalities. Let's have a review first. General forms of quadratic inequalities: ax squared plus bx plus c greater than 0, ax squared plus bx plus c less than 0, ax squared plus bx plus c less than or equal to 0, ax squared plus bx plus c greater than or equal to 0. So let's find the solution set of 3x squared minus 3x minus 18 less than or equal to 0. First, let's rewrite this equation into a quadratic equation. 3x squared minus 3x minus 18 equal to 0. Then let's factor out 3x squared minus 3x minus 18 equals to 0. So the factor of 3x squared minus 3x minus 18, let's simplify this one first. Let's divide by their common factor. Let's divide it by 3. You will get x squared minus x minus 6 equal to 0. Then let's factor x squared minus x minus 6 equal to 0. Factor of 6, that when you add gives negative 1. So factor of 6, 2 and 3. X minus 3 plus 2. Then equate this one into equal to 0. So your root is x minus 3 equal to 0 and x plus 2 equal to 0 becomes x equals to 3 and x equals to negative 2. This now is your critical point. X is equal to 3 and x is equals to negative 2. Let's plot this one on a number line. So negative 2 and positive 3. So let's mark the critical point 3. I use the solid circle because 3 is included, less than or equal to, and negative 2. As you can see, we have 3 regions. Our number lines divided into 3 regions. The first, on the left, the middle region, and the third region. Now let's test our region if this one satisfies on our equation. Let's just use the factored form so we can easily check. The first region is on the right of negative 2. Let's check if x is less than negative 2. So let's have any value on the left. You can choose. You can choose negative 3, negative 4, negative 5. I will just choose the small one, negative 3. So if x is equals to negative 3, and then let's substitute on our factored form. So negative So, negative 3 minus 3 times negative 3 plus 2. Let's check if this one is less than or equal to 0. Negative 3 minus 3, negative 6 times negative 3 plus 2, negative 1, less than or equal to 0. Negative 6 times negative 1, positive 6, less than or equal to 0. Is 6 less than or equal to 0? No, because 6 is greater than or equal to 0. So the first region is false. 6 is not less than or equal to 0. So if x is less than negative 2, it will not satisfy our equation. Let's check the second region. Let's get a number in between negative 2 and 3. I will just choose the small one, 0. If x is equal to 0, so we can easily substitute to our factor form. Let's say x is equal to 0. Then, let's substitute here in our factor form. X, 0 minus 3 times 0 plus 2. Let's check if this one is less than or equal to 0. 0 minus 3, negative 3, times 0 plus 2, 2, less than equal 0. Negative 3 times 2, negative 6, less than or equal to 0. Is negative 6 less than or equal to 0? Yes. So, it's true. Our second region is true. Next, the third region on the right. So if x is greater than 3, we have 4, 5, 6, and so on. Let's just choose 4. If x is equals to 4, okay, let's test. 4 minus 3 times 4 plus 2. Is this less than or equal to 0? 4 minus 3, 1 times 4 plus 2, 6, less than equal 0. 1 times 6, 6, less than equal to 0. Is 6 less than or equal to 0? No. False. Therefore, the range of values that satisfy 3x squared minus 3x minus 18 is from negative 2 to 3. Therefore, solution set is negative 2 less than or equal x less than equal 3. Means negative 2 is included. We use the solid circle because this one is less than or equal. It means the value negative 2, negative 1, 0, 1, 2, and 3.